Most people think modern energy systems are purely a product of recent technology: solar panels, batteries, smart grids, high-efficiency heaters. But if you look closer at how humans originally solved the problem of heating spaces, you start to see that many of today's ideas are actually built on very old patterns. And that's where this story begins. Because long before electricity was widely available, early heating methods were already solving a problem that still exists today: how to generate and retain usable energy in a controlled environment. At the time, people didn't think in terms of energy systems. They thought in terms of survival: how to stay warm, how to cook food, how to store heat for as long as possible. And those constraints forced a level of practical innovation that still influences modern energy thinking. Early heating methods like wood stoves, enclosed fire systems, and insulated hearth designs were not just about burning fuel. They were about controlling energy loss. Because heat is only useful if it can be contained long enough to serve a purpose. That simple idea becomes more important the more you look at it. Most early systems were built around three core principles: generate heat, contain heat, distribute heat efficiently. And interestingly, those same principles still show up in modern systems today. The visible technology has changed dramatically, but the underlying logic hasn't. When modern engineers design heating systems, they're still solving the same three problems, just with different tools. Electric heaters replace fire. Insulation replaces thick stone walls. Smart thermostats replace manual control. But the structure underneath remains surprisingly similar. And that's where the hidden connection becomes clear. The real foundation of modern energy systems didn't start with electricity. It started with managing heat. Because heat is the most basic form of usable energy in everyday life. And early heating methods were the first large-scale attempt to control that energy in a predictable way. As communities evolved, these methods became more sophisticated. Homes were designed to retain warmth more efficiently. Materials were selected based on thermal properties. Even the layout of living spaces began to reflect heat distribution patterns. In other words, architecture itself became part of the energy system. And that idea carries forward into modern design more than most people realize. Today's energy-efficient homes still follow the same logic: reduce loss, improve retention, control distribution. Even renewable energy systems like solar heating and modern insulation techniques are extensions of those same early principles. The difference is scale and precision, not concept. But there's another layer to this story. Early heating wasn't just about comfort. It was about dependency. People had to constantly manage fuel sources, maintain fires, and monitor conditions to keep systems running. That created a direct relationship between human behavior and energy availability. And while modern systems have automated much of that process, the dependency hasn't disappeared, it has just shifted. From firewood to electricity. From manual control to infrastructure. And that shift is important, because it changes how people perceive energy. What once required active management now feels invisible. Until something goes wrong. Then the underlying system becomes visible again very quickly. That's why understanding early heating methods is useful today. Not because we want to go back to them, but because they reveal the core principles that still govern modern energy systems. Energy must be generated. It must be controlled. And it must be retained long enough to be useful. Those rules haven't changed. Only the tools have. And when you understand that continuity, modern energy solutions start to make more sense, not as completely new inventions, but as evolved versions of very old ideas. From that perspective, early heating methods weren't primitive. They were foundational. And they quietly shaped the way we design, use, and think about energy even today. If you want to go deeper into how these principles evolved into modern systems, there's a structured breakdown in the description. You can also find a practical guide that connects historical methods with today's real-world energy solutions. And as always, the goal isn't to romanticize the past. It's to understand how deeply it still influences the present.